Hello, let us try to see how to solve this problem. What is asked is the current through the 2 kilo ohm resistance in the circuit shown is. So basically, what it is asked is this is basically a circuit given, and we just want to determine the current through the 2 kilo ohm resistor. So for this, basically we need to understand the concept of Wheatstone's bridge. So what is Wheatstone's bridge? Basically, we have resistors arranged in a diagonal shape. Okay, okay, and let us assume we have some element here. Okay, so this is the input where we apply the voltage, and this basically is the loop back. Now let us assume this is P. Okay, and this is Q, this is R, this is S. So the principle of Wheatstone's bridge is, so here if P by Q is equal to R by S. That means the ratio of resistance of P and Q, if that is equal to ratio of resistance of R and S, then it is called a balanced Wheatstone bridge. Wheatstone. Okay. So this basically is used for instrumentation purposes. So Wheatstone. Okay. So this bridge, right now, if we imply this here, this is P, this is Q, this is R, this is S. Now what happens is, if P by Q is equal to R by S, this is called a balanced Wheatstone bridge. That means the potential here and here will be the same, which meant the current through the center path will be zero. That means this basically is a open circuit. So that's what it means. Now if you see here, if we apply the same here, this is P and this is Q. P by Q is equal to 1K by 1K, right? Which is equal to 1. And then R by S is again 1K by 1K, which is equal to 1. So that means P by Q is equal to R by S, which means the current through the 2 kilo ohm resistor is 0. That means the potential at C is equal to potential at D. VC is equal to VD, or we can also say VCD is equal to 0. So for a balanced Wheatstone bridge, the current through the center arm is 0. That's how we have to solve this problem.